Welcome to The Explainer. Today, we're going to talk about a problem I'm sure many of you have faced. We're going to take a massive development Docker image and turn it into something lean, mean, and production-ready. Let's dive in.
So picture this. You've built your application. It's running perfectly on your local machine. You go to Dockerize it, and then you see the image size. A whopping 1.7 gigabytes. Why on earth is it so big? Now, this kind of bloat might be okay for development, but once you start thinking about production, it becomes a huge problem.
And just look at this gap. We're starting with this massive 1.77 gig image, but where we want to be is this tiny 149 megabytes. Now, this difference isn't just about saving some disk space. It has a real impact on how fast you can deploy, how much you're paying for cloud storage, and your overall security posture. Our mission today is to close this gap.
This quote really just hits the nail on the head. The things that make our lives easy during development are often the exact opposite of what we need for an efficient production environment. You know, these dev images are just stuffed with compilers, build tools, hot reloading utilities, things that have absolutely no business being in a final container.
I love this analogy. It's perfect. Your dev environment is like a messy kitchen. It's got all the tools, all the ingredients, maybe some eggshells on the counter. But your production image, that should be just the finished cake. Perfectly plated and ready to serve. You don't serve your guests the whole messy kitchen.
So our first step on this optimization journey is probably the simplest, and honestly, it often has the biggest impact. It's all about just choosing a better starting point, a better base image.
Just check out the dramatic size difference between these official Python tags. The default image, the one most people grab first, is based on a full Debian operating system, which is why it's so huge. But just by switching to a slim tag, you get a massive reduction. And then you have the Alpine tag, which is built on an incredibly minimal Linux distribution, and it's even smaller. And just like that, with one simple change, just switching our base image to Python 3.14 Alpine, we have absolutely crushed our image size. We've gone from 1.7 gigs all the way down to just 226 megs. That is a fantastic start.
But a good foundation isn't the whole story. How we build on top of that foundation matters just as much. So for our next step, we've got to talk about Docker layers.
So here is a super common mistake. I see it all the time. A developer installs a build tool, like UV, in one step. Then they use it to install dependencies in the next step. And then they try to be tidy and clean it up by uninstalling it in a third step. I mean, it seems logical, right? But here's the catch. That's not how Docker works. This is the key concept you have to understand. Docker images are built from layers that stack on top of each other, and every single layer is additive. That uninstall command doesn't actually remove the data. It just adds a new layer on top that marks the files as deleted. The original tool is still buried in a previous layer, taking up space.
So the real solution is to do the entire operation, install the tool, use a tool, and then get rid of the tool, all within a single run command. By chaining them together with and, you create one single clean layer where that build tool never actually gets committed to the image history.
And by applying this one little trick, look at that. We've shaved off even more, bringing our image all the way down to a lean 156 megabytes. We are getting really close to our goal now.
We've made some incredible progress, but if you want the most powerful, the most elegant way to separate that messy kitchen from the final cake, it's time to talk about the ultimate solution: multi-stage builds.
A multi-stage build is pretty much exactly what it sounds like. You use multiple from instructions right inside a single Docker file. The first stage acts as this temporary build environment, where you can make all the mess you want, and then you just selectively copy only the finished product over to a clean final stage.
And this visual really shows the power of this approach. Stage 1, our builder, it uses a full-sized image with all the compilers and tools it needs to do the heavy lifting. Then, Stage 2 starts completely fresh with a minimal Alpine image and simply copies the finished application from the builder. The entire messy build environment just gets thrown away.
And the final result? A production-perfect image at just 149 megabytes. We hit our goal. By applying these three techniques, we went from 1.77 gigs all the way down to 149 megs. That is brilliant. Okay, so we did all this work, we spent all this time shrinking an image, but so what? Why does this actually matter in the real world? What's the big payoff here?
Well, the benefits are huge. Deployments are way faster because there's just less to download. Your cloud bills are lower because you're storing and transferring less data. Your CI/CD pipelines run quicker.
And, maybe most importantly, your application is more secure because you've stripped out dozens of unnecessary packages, which dramatically shrinks your potential attack surface.
We've optimized for size, which is a fantastic step forward for security, but the journey doesn't quite end here. The next logical steps are things like making sure you're not running as the root user inside your container and performing regular vulnerability scans. A small image is great, but a small and secure image, that's the ultimate goal. Thanks for watching.